In today's lab, we're going to be studying resistors. So resistance is the property of a material to resist the flow of electricity, and it's defined as the material's resistivity times the resistor's length divided by the cross-sectional area of the resistor. So length and area, those are fairly self-explanatory, but the resistivity is just a quantity that describes how resistive a specific material is. So different materials are going to resist electricity differently, more or less than others, and so the resistivity is just a quantity that describes how resistive a specific material is. Now, because length is on the top in that formula, if you increase the resistor's length, then you're going to increase the resistance of that resistor. And likewise, area is on the bottom, so if you increase the area, the cross-sectional area of the resistor, then you're going to decrease the total resistance. Now, as we've talked about previously, there are two ways to combine resistors, series and parallel. So when you combine them in series, you're just putting them all end to end, all in a row, and that's effectively increasing the resistor's length, which increases the total resistance. So if you wanted to find the total equivalent resistance for series resistors, it's just the sum of the individual resistors. So our total would be R1 plus R2 plus R3 and so on. When you combine resistors in parallel, you're going to connect the tops together and the bottoms together. And this effectively increases the cross-sectional area of the resistor because now you have more resistors for the current to flow through, so it's kind of the same thing as increasing the area, which then decreases the total resistance. Now to find the total parallel resistance, it's a little different than finding it for series resistors. For series, you just add up the individual resistances. But for parallel, you have to add up 1 over the resistances. So 1 over R total is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So for this lab, we have two sets of experiments. First, we'll look at resistance and length, and second, we'll look at resistance and area. For resistance and length, we have two parts. First, we're going to make resistors out of conductive paper and conductive tape, and then we'll vary the length of the resistor and measure the resulting resistance. And then second, we're going to use our resistor components and combine them in series and compare our predictions to the measured series resistance. For the paper resistors, we need to cut off a 1 centimeter strip from the conductive paper, and I'm going to use this paper that I've already cut some off of, but you'll probably have a full sheet. So I'm just going to cut off 1 centimeter from this. You'll notice that it is a centimeter grid on here, so each one of these lines is a centimeter. So I just need to cut along there and follow that line, and we'll remove a 1 centimeter strip from the paper. You'll notice that I've left the top margin and the bottom margin of the paper on there, and we're going to use that, so make sure you don't cut that off. Now we need to cut some pieces from our conductive tape, and we need to do this the same width as our paper strip. So you're just going to measure this, and we need to make 11 pieces of the conductive tape. So what I'm going to do now is apply a piece of the conductive tape to each end of the conductive paper. And we left the margins on so that I can put one at each end, so it's going to be in the margin, and there will be 20 centimeters in between the two pieces of tape. Now I've got the conductive tape applied to each end of the conductive paper, and you'll notice that if I measure it from one end to the other, that we have 20 centimeters in between the two pieces of conductive tape. So from the inside edge of this piece to the inside edge of this piece, we have exactly 20 centimeters. Now just grab your multimeter, and we're going to use this to measure the resistance of our paper resistor. So as we've done before, make sure that the probes are in the correct ports. We want black in comm and red in ohms. We're measuring resistance. And then turn the dial down to the 200 kilo ohm range for resistance. Now when you measure the resistance, you need to put the probes on the same point for each measurement. I found that if you vary the position on the conductive tape, it can change the resistance just a little bit and introduce more error. So if you want to reduce the error, choose the same point for each of your measurements. And what I'm going to do is put it on the edge. So it's still on the conductive tape, but it's right on the edge, just right before the paper. So I'm going to do that on both sides, and we've got 68.6 kilo ohms. I'm just going to write this down. We'll have the length, which was 20, and this is units of centimeters. And then we had the resistance in units of kilo ohms, and that value was 68.6. Now we need to apply another piece of conductive tape, and we're going to apply this one 2 centimeters closer than the other one. So now the distance between the two will be 18 centimeters. So I'm going to place this one right here. And now if I measure, we have 18 centimeters between those two pieces of conductive tape. But I can't leave this previous one on, so I'll just need to use the scissors and cut that one off. Now our length is 18 centimeters, and we'll do another resistance measurement. Again, make sure that you use the same points for your measurement. And now we've got 61.6 or 61.5 kilo ohms. So I've just recorded 18 centimeters and 61.5 kilo ohms. Then again, we'll apply another piece of conductive tape, and this one will be 2 centimeters closer. So now the distance between the two pieces will be 16 centimeters. So now we've got 16 centimeters between these two pieces. And again, we need to cut off the extra where the previous one was, or it will affect our measurement. Then we'll make another measurement, and again, choose the same points on the conductive tape for your measurement. And we've got 54.8 kilo ohms. So we're just going to continue this process. We'll add another piece of conductive tape, trim off the extra, and make a measurement. And you'll just keep going until you get down to 2 centimeters long. So let's just do that. 14 centimeters. Trim off the extra and make a measurement. This is now the last measurement. We've got 4 centimeters in between from the previous one, and I'm just going to apply one last piece of conductive tape. So now the distance between the conductive tape strips will be 2 centimeters. And we can just verify again. Yep, 2 centimeters, and then cut off the previous strip. So that's it for this part of the experiment. We've made resistance measurements on strips from 20 centimeters all the way down to 2 centimeters, and you've got the length and the resistance measurements for each one of those. Now we're going to measure the individual and series resistance of our resistor components. So find your bag of resistors, and we're going to look for the 1 kilo ohm, 2 kilo ohm, and 3 kilo ohm resistors. When you first look at resistors, they can be kind of confusing. They've got all these different colors on them, and you're not sure what they mean. But the different colors represent different nominal resistance values. Normally there are 4 colors for a resistor. Sometimes there's 5 or 6 or 3, but normally it's 4. So you'll look at them and we'll have 3 colors that represent the value, and then the last color band represents the tolerance, or how accurate or close the value is, the measured value is, to the nominal value. So the resistors we need today are brown, black, red, and then the tolerance, so that's our 1 kilo ohm, and then red, black, red is our 2 kilo ohm, and orange, black, red is the 3 kilo ohm. And the last color in this case is gold. That represents plus or minus 5%, a 5% tolerance. First, we need to measure the individual resistance of each one of these resistors, and I'll show you 2 ways that you can do that. First is you'll just hold the probes on there, and you'll want this either on the 20 kilo ohm range or the 2000 ohm range. I'm just going to leave it on the 20K range for now. So I'm just going to hold the probes against the resistor wires, and it looks like we've got 0.96 kilo ohms. The other way you can do it is just put it into the breadboard, and you'll want to bend it down so that both ends of the resistor are in holes. Then what you want to do is press the probe tips down into the little recessed region around the hole. It's not actually going to be inserted into the hole because the probe tips are too big, but you can kind of just press it in there and it kind of holds it in place so that it's not going to move around too easily. And looks like we've got 0.98 kiloohms. So just record the measured value that you recorded with the multimeter as well as the nominal value, which was 1 kiloohm. Then I'm going to do the same thing for the other resistors. Just going to use the breadboard method real quick. So just put that in there. Again, place the probe tips down into the holes a little bit, and we've got 1.96 kiloohms. And we'll do the same thing with the last one and get the measured resistance for that. So this is the 3 kiloohm one. And looks like we've got 2.92 kiloohms. So just make sure that you record the measured values from your multimeter as well as the nominal values of 1 kiloohm, 2 kiloohms, and 3 kiloohms. The last thing we need to do is combine these in series, and then we can measure the total series resistance. So the way you want to do this is put the first one in so that its two ends are in different rows, and then we'll put the next one in so that one end is in the same row as the end from the previous one, and then we'll put the other end of that one in its own row, and then again with the last one so that we've got one end of it in the same row as this one. So I've got the 1K, 2K, and 3K resistors, and the two ends here are together and the two ends here are together. Then we just need to measure the total resistance across all three of them. So I'll do that the same way as I did the individual resistances. I just put that at one end of it and then put this at the other end, and we measure the resistance across all three of them. So that's it for the resistance and length experiments. When you're done with this part, just make sure to shut off the multimeter to save the battery. Now, if you're not going on to the second set of experiments with resistance and area, that's fine, but just make sure to read your instructions carefully. They will have more information than what is shared in the video. And now I'm going to get started on that second part. For resistance and area, we'll again have two parts. First, we'll make some resistors out of conductive paper and conductive tape. And then second, we'll use our resistor components, measure their individual resistances, and then combine them in parallel and find the total parallel resistance. First, we need to cut our sheet of conductive paper into 7 pieces, and we'll have widths of 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, all the way up to 7 centimeters. And we'll exclude the left and right margins. So first, I'll just start by cutting off the outside margin here. We're going to keep the top and bottom margin, but we'll get rid of the left and the right margin. Now I've got the left and right margins removed, so I'll cut the remaining portion of the paper into 7 strips with widths of 1 centimeter, 2 centimeters, and so on. Now I've got my conductive paper cut into 7 strips along with the left and right margins. Like I said, we don't need the left and right margins, so I can toss those ones out. But we will use the top and the bottom margins of each strip, so make sure you keep those attached. Now we need to cut some pieces of conductive tape, and we're going to do 2 pieces for every strip of paper. And they need to be the same width as that strip of paper. So I'll just take the 1 centimeter strip, line that one up, mark it off, cut it, and I'll just do that twice, so I have one for each end. Then I'm going to apply the conductive tape to each end of the paper, and we're going to do it just outside the 20 centimeter area, the 20 centimeter grid area. So now in between these 2 pieces of tape will be 20 centimeters of paper. Then we can just verify that it is 20 centimeters from the inside edge of this piece of conductive tape to the inside edge of the other piece. So this area in between is 20 centimeters. Then we're going to do the same thing for each of the other strips. So again, I'll just measure off a piece of conductive tape now for the 2 centimeter strip. So I've got both of my 2 centimeter pieces of conductive tape. Again, we'll just remove the backing from this and apply it on the margins so that we've got 20 centimeters in between the two strips of conductive tape. It's important that the length be the same for each one of these strips, the length of paper in between each one, because we want to keep the length constant for each one of these. Now I've got all of my paper resistors with a length of 20 centimeters in between the two pieces of conductive tape, and they have widths of 1 centimeter, 2 centimeters, 3, 4, 5, 6, and 7 centimeters. Now the reason we're varying the width of our strips of paper is because area is equal to length times width, right? So if you think of the cross-sectional area of these strips of paper as a rectangle, just a very thin rectangle, then the area is going to be the thickness of the paper times the width of the paper. We can't really vary the thickness of the paper, but we can vary the width. And so by varying the width of the paper, we are varying the area. Now just grab your multimeter, and we're going to use this to measure the resistance of each one of our paper resistors. So make sure you've got the probes in the correct ports. We want black in COM and red in ohms, so look for the omega symbol. Then we're going to turn the dial to the 200 kilo ohm range for measuring ohms, and then we'll just measure the resistance of each one of our paper resistors. So for each of these measurements, try to place your probe tips in the same place relatively on the conductive tape. I found that if you vary it too much, if you have it farther out, it might increase or reduce the resistance just a little bit. So if you want to reduce the error, just try to choose the same point. I'm going to do the inside edge here right in the center. And it looks like 200 kilo ohms is too low for this, so I'm going to go up to the 20 mega ohm range. And you might need to do that too. So let's see, what do we get now? So we got 0.32, so this is now in mega ohms, so that's actually 0.32 mega ohms or 320 kilo ohms. So for each of these measurements, you're going to want to record the width of the paper in centimeters, as well as the resistance in kilo ohms. So we had the width of 1 centimeter, and a resistance of 320 kilo ohms. Now we're going to do the same thing with our next strip. So this is the 2 centimeter wide strip. And again, choose the same placement as you did on the previous one. So again, I'm going to do the inside edge in the center. So it is still on the conductive tape, but it's just barely in from the edge. All right, so that one looks like it's below the 200K range. So we can go back to the 200K range for this measurement. And we've got 153.3 kilo ohms. So just like before, we've got our width, and that is now 2 centimeters, and then our resistance is 153.3 kilo ohms. And you'll have a different value because it'll vary somewhat based on how you made your resistor. So I'm just going to go on again, and we'll measure it for the 3 centimeter strip. Again, I'll do it in the center on the edge there. Now I've got 100.4, 0.3, okay, 100.3 kilo ohms. So I'm just going to continue this process. Again, now we'll measure the 4 centimeter strip, place the probe tips in the same place, record the resistance. Do that now with the 5 centimeter strip, place it there, get that, and I'll just do it again then with the 6 and the 7 centimeter strips. Each time record the width of the strip as well as the resistance in kilo ohms. Or you could do it in ohms if you want. It's up to you. So that's it for the paper resistors. Now we need the resistor components. And for these we need the 1 kilo ohm, 2 kilo ohm, and 3 kilo ohm resistors. And I know that these can kind of be confusing when you first look at them. You've got all these different colors on them and you're not sure what they mean. But the different colors represent the nominal resistance value, the value that the resistor should be. And usually they are 4 colors. Sometimes you'll have 5 or 6 or less or whatever. But normally we have 4. And in that case, we would have 3 colors for the nominal value, and then the 4th color is the tolerance, or how accurate, how close is it to the nominal value. So For the 1 kilo ohm here, I've got brown, black, red, and then gold. So brown, black, red, that's 1 kilo ohm, and then gold means plus or minus 5%. So it could be within 5% of 1 kilo ohm. Then we've got 2 kilo ohms, which is red, black, red, and then 3 kilo ohms is orange, black, red. And each one of these have a gold tolerance band on them. Yours might be different, but the important one is the first three. So brown, black, red for 1K, red, black, red for 2K, and orange, black, red for 3K. So first we need to measure the individual resistances, and then we'll measure the parallel resistance. So for the individual resistance, let's turn it down to 20K, so that's 20 kilo ohms maximum. And then let me get my 1 kilo ohm resistor, and I'm going to show you two different ways that you can measure the individual resistance. One way is you can just press the resistor leads against the probe tips, and I've got 0.98, 0.97 kilo ohms. The other way you can do it is to put it inside the breadboard. So just put one end of the resistor in separate rows. So each end of the resistor should be in a separate row. Then what you want to do is just press the probe tips into the recessed region around the hole. So it's not actually going to go into the hole because the probe tip is too big, but you'll just kind of press it into that dent around the hole and you can get the value. So again, I've got 0.98 kilo ohms. Then I'll do the same thing with the other resistors. So I've got the 2K here. Again, I'll just place it inside the breadboard and put the probe tips against the metal leads. And I've got 1.97, 1.96 kilo ohms. And last, I'll do the same thing with the 3 kilo ohm resistor. So again, just place it in the breadboard, each end in a separate row, and press the probe tips in. We've got 2.92 kilo ohms. So just make sure to record the nominal values, the 1 kilo ohm, 2 kilo ohm, 3 kilo ohm, as well as the measured resistance, whatever those are for your resistors. The last thing we need to do is combine these in parallel. For this, just make sure that you plug each one into the same row. So you'll have one end of each one in the same row as the other ones. So let me just get these in here and I'll show you what I mean. So in my case, I've got the bottom ends here in row, looks like 37, and then the top ones in row 28. So just make sure you have all the bottoms together and all the tops together, and then you can measure the parallel resistance across all of them. So then as before, just place one probe tip against the leads on the top and then one on the bottom. And it doesn't matter if you do it on the same resistor because they're all connected underneath in the same row. It'll give you the same value either way. So just measure that and record your parallel resistance. And that's it for this experiment. So when you finish, just make sure to turn off the multimeter so that you save the battery, otherwise it won't automatically shut off. And as always, read your instructions carefully. They will have more information than what is shared in the video. And good luck on your experiment.